I have been at Western now for 7 years, and since I moved to Western, my research has really transitioned more to look at, or really transitioned to look at inland coastal water, and in particular for the Great Lakes, looking at the potential of the contribution of groundwater to and its effect on nearshore water quality. So whether that be, looking at questions, is groundwater delivering nutrients into the nearshore waters of the Great Lakes? What's the role of groundwater lake interactions in controlling E. coli levels, fecal indicator bacteria at beaches of the Great Lakes? So a lot of my work kind of comes from translating what a lot of the large body of work that's been done in marine environments to now the inland coastal environment, and looking at those groundwater, coastal water interactions.
Okay. My name is Ming Wu. I'm a postdoc within Claire's group. I too am from Australia, but from the other side of Australia, from Perth. I did my PhD back in Australia a few years ago on environmental remediation of soils, but my background has always been groundwater modelling and development of modelling codes. So within Claire's group, I'm looking at using groundwater models to try and better understand bacteria transport onto beaches and how it and how it's transported within the beaches. We also have projects looking at nutrients from septic tank plumes and modifying the software codes as well.
So I would say within my research group, we do a lot of field work in the summer, but we couple that with lab experiments and also numerical modelling. So Ming's essentially, he does help out in the field, but he's a computer modelling guy. So using kind of complex numerical models to actually understand how contaminants or bacteria kind of move in this environment.
So you're taking all that data and synthesizing it into something that we can understand.
Yes.
Okay.
Yeah.
Good. So why Canada? Why did you guys come to Canada? What made it, is it just easier coming here because it's part of the Commonwealth, so it's an easier transition for you, or was it just there was the openings up here that looked really interesting, or why travel all the way around the world?
Around the world, yeah. It's a great place to be. Where else would you be but London, Ontario? Well, Western's it's a great university to work at. But I guess after my PhD, I left Australia. I spent 18 months at EPFL in Switzerland, and I did a postdoctorate there. And after that, I spent a year in Bangladesh, working with a water supply and sanitation NGO in Bangladesh. And after that, I had worked previously with someone at Western, and they were actually the initial reason I came to Western was because they were starting up a civil engineering and international development program, and I had been working in Bangladesh. I had experience in research and academia, and so I actually originally came. I used to coordinate that international development program. And so I came, and so that's what attracted me here, because they were building that program. And then once I came here and I started setting up my research program, there was this whole, opening in terms of, these unanswered questions about what is the role of groundwater in terms of the Great Lakes. It's really, I think there's a lot of excellent researchers within Canada, looking at groundwater remediation, looking at, transport of NAPL contaminants. There's less research, I think, involved in groundwater surface water interactions. So I think there are some very good researchers in that area as well, but there's a lot of unanswered questions in terms of groundwater as this source that people often don't consider as a source of nutrients or other contaminants if you've got industrial sites that are just sitting on the Great Lakes. And so, it's been great because I've been able to transfer what I've done before and apply this in the inland coastal waters.
And then what brought you here?
Me. I took a slightly different path. So I did all my education in my first postdoc in Australia, and then came out here. Essentially, this was my first posting overseas with Claire's group. It was definitely, I think at that point I was looking at possibilities within Australia and overseas, and this was definitely one of the best options I had. Yeah, definitely. Canada has a very good reputation in terms of groundwater research, in terms of the remediation network. So it was definitely familiar to me in terms of that.
Okay.
And then also just the opportunity to work with Claire's group. The beach zone is not an area that I've done much work in, but it's also a very dynamic zone that changes. That changes, and that changes quite rapidly. But also, it's quite an important impact on nutrient cycling and other things as well. So yeah, it's definitely a very good opportunity for me.
How was the transition from Australia to here? Is it fairly, I mean, similar culturally wise, and then like how was the process of actually having to like move out of country for? Because a lot of folks in the U.S. we usually just stay within it. So some of the folks might be interested, like how hard is it to transfer between countries if you want to go study in another country? Because you've got this great opportunity, but sometimes I think it might be difficult because you're going out of country. So how easy was that transfer?
Yeah, I mean, well, I think for studying, like if it's for grad studies, it's, as long as the funding's available, it's relatively straightforward. Like we have at the moment, some of my PhD students are from the States, and I think it's a pretty, simple transition to be moving at kind of a graduate level. At a faculty level, I mean, I would say for me, it's been excellent in terms of my career because it has opened up a lot of different doors, and I never would have looked at the Great Lakes and seen these unanswered questions if I hadn't actually relocated to Canada. Otherwise, you're really focusing on the same kind of issues that maybe you're looking at for your PhD or thinking about for your postdoc. But I mean, I would say in terms of the transition, it is more. The first couple of years as a new faculty member, I'd say it's a little bit more difficult because you don't have a network.
Okay.
You start, and if I was in Australia, I know people at the Ministry of the Environment. I know people at CSI, like the research bodies there, or the different ministries or government agencies. When you move to a new country, you don't know. You have to work out what the landscape is.
Right.
You have to work out who does what, who has what kind of equipment, who you can collaborate with. So it takes a whole, it takes a couple of years to build that and to build up a new network.
To really be up and running and full speed.
Yeah, and to work out like what are the questions in this landscape. Like if in Australia the research, the questions are different, a lot driven by water quantity, whereas here, say within the Great Lakes setting, we've got a different set of questions and how can you adapt and modify your research program to answer those questions, and how can you, for a lot of grants within Canada, you need support, supporting partners, which is good because you're working closely with government agencies, but you need to develop those partnerships.
Right.
And so developing partnerships is really important, but it takes time.
I think I'm
Ming can
definitely,
talk from the
I'm definitely still in the process of trying to figure out who the important parties are and building up my own network contacts as well. So yeah, it's definitely been interesting.
And I would think too, like just being able to like put your face in front of their face and be able to get to meet and know each other and know who you're going to be able to work with and how to work with them, because everyone's got their own personalities and things like that. So learning how to adjust to each and every person and figure out, okay, these are the folks I can go and talk to get what it is that needs done. And so
and I think these days, I mean, there's such a drive and a need for interdisciplinary collaboration that you need to work out who does things before you can even start initiating things, and who will be, whether it's someone within the university or whether you're looking at other universities.
Yeah, because you're thinking, the whole funding process and everything, you have to have that all set up so far in advance before you even go out into the field, and you need to know who it is you're going to be working with while you're applying for that funding. And so you're talking years ahead of time sometimes before you're actually putting your boots on the ground to do the work.
And also the funding body, like in Australia we have the ARC, which is kind of the main research funding body. Here we have NSERC. The programs are different. They value slightly different metrics. So you got to understand the funding landscape as well. And understand, so in Canada, often if a company can put $20,000 into doing research, you can match that and make that into a $60,000 funding grant. But you need to know what the mechanisms are to do that.
You're just going to be sitting out there in the wind with nothing to do. Agreed. got time, I want to do research, I'm just going to help out.
Yeah, I mean, I was fortunate though because I do a lot of computer modeling.
Okay.
So I'd say in my first couple of years, even it's expensive obviously to go into the field and do water quality analyses. It rapidly builds up, so you need to have funding for that. But in terms of computer modeling, you need a computer.
Yeah. And that's pretty
There's
good.
a lot
You're
of,
good to go.
There's a lot of great software available. You need a
Yeah.
computer. You need money for a couple of grad students, and then you, as a new faculty member, you can
you don't
wrap
even
things
really
up.
need a lab. You can just throw them out here in the atrium and just say,
Yeah.
all right, there you go. Here's
Yeah.
your office, and have at it. So.
Yeah.
But I guess it gives you that time to build up that momentum.
Yeah.
As a researcher.
Yeah.
So speaking of water quality and stuff, exactly where in the Great Lakes do you do most of your research?
So we do a lot of what we do. Well, yeah, we do work on Lake Huron.
Okay.
We do work on Lake Erie, up in Georgian Bay, further
Okay.
north in Lake Huron, and more recently we're doing work in Lake Simcoe as well, which is
Okay.
a large inland lake in Ontario, just north of Toronto. But we, it kind of depends what the problem, or we do work on the Toronto beaches if we're
Okay.
looking at, it depends kind of what the research question is. So for instance, for the work that we do looking at beach water quality, you know, just as background, a lot of studies, you know, over the last 10 years have shown how, so when you go to a beach and a beach is closed,
Right.
or it has an advisory, that's because E. coli counts
Right.
are above a certain level. And in the last 10 years or so, it's been shown how E. coli counts are much higher in the sand and the groundwater than in the surface water where the health units are actually taking their measurements. So we're interested in it because we do groundwater, coastal water interactions, and we want to understand why E. coli builds up in the beach sand and under what conditions it will be released. So for that, we do work on the beaches in Toronto because they're often, you know, in urban environments, you can have higher levels of E. coli. But we also work a little bit out on Ipperwash, which is a beach near here, looking at how, you know, when you have how E. coli can be released from the beach sand during wave events or rainfall effects.
So do you think like the beach sand's kind of becoming a reservoir, so it's like being deposited there by the wave action brought in, and it's sitting there, and then it can be released back out? Is that
Essentially.
Okay.
So it depends. Like some beaches where you've got really high bird populations, you can get, you know, E. coli just being directly delivered into the beach sand. But generally, I think in a lot of beaches, which, you know, particularly one of our beach sites, which is quite rural, there's not a lot of sources. So we think what happens is you've got lower concentrations of E. coli in the lake, and then it just recirculates, it builds up over time within the beach sand, so you get this reservoir. And there's kind of controversy over whether, you know, replicates or what happens to the bacteria in the sand, but then you have wave conditions that come through, so any wind, you get wind-driven waves, and that will mobilize and stir up the sand, and it will be released into the water, which will then cause an advisory. So it's an issue because it will cause an advisory when it's released. But the other issue is that that's where all the kids play, right? So you go to a beach and that's where you have kids you know, playing in the sand.
Yeah, you gotta make your sandcastle.
Yeah. And that's where they eat the sand, and that's often the area
I remember
where...
eating the sand when I was a kid. I'll have to ask my mom about that.
And the other thing we often find is that more sheltered beaches, which is often where parents will go with their children, because they're safer beaches, because you don't have, you know, any waves or those beaches we often find higher levels in the sand as well, because you're not having it more regularly being stirred up by the waves.
So it's just kind of settling there and staying there.
It settles there, it infiltrates in, and there's nothing that's kind of remobilizing it out.
Okay. Like with that, do you find that wildlife is more the problem, or is the urban population the problem? Because you can get E. coli both from humans and wildlife. So are you guys trying to differentiate where the E. coli is coming from, or are you just basically just going and seeing where it is?
No, we have done some microbial source tracking work. So I do work with a researcher in Amara McKenna, and he does the kind of microbial source tracking. So looking at the human marker to see whether it's, you know, related to the human source. So that's part of it as well. And there's a lot of other, you know, really great researchers in the Great Lakes as well who are looking at, you know, other pathogens. So, you know, we see E. coli in the beach sand. It's not necessarily a health risk. So there are other are there pathogens that are there that and what's their behaviour relative to the indicator? Because that's a question as well. It's about, we use E. coli at the moment. Is that the
best way to track it?
Yeah.
Yeah. My lab, one of our former grad students, he was part of a dual lab project where we were more the wildlife side of it, and so we were using dogs to chase bulls off beaches, and then the microbiology side of it was that lab they were going out and testing to see, all right, what's the differences in the E. coli levels, where we've been chasing bulls versus where we hadn't been, and so I haven't quite found out the full answer to that yet, if it actually is having an impact as far as the E. coli levels. I know that there definitely was a big impact with the number of bulls that were there. It was pretty successful with chasing it off. So
they were just getting dogs onto the beach.
Yeah, so they're just like the dogs that they use to chase birds away from airports, a lot of things like that. They're using that same kind of dog, and they just would go out and just harass the birds all day long. And so they were just sitting there on the beach for 12 hours a day and just letting the dogs go. And it was kind of funny. My lab mate, he's got blonde hair, but he came back with hair that was almost like just the neon glow of yellow that just looked so weird after being out on the beach all summer long. Yeah. But no, it's really interesting because you think of all the number of times that you have beach closures. I mean, that makes a big impact on the economy of those particular towns. Because along Lake Michigan, those are huge resort towns there, and if those beaches are closed, that has, just the daily impact alone, you're talking tens to hundreds of thousands of dollars that the economy just lost because that beach was closed. And so I think...
And I don't know what the current... there are statistics out there for how much money, how many millions they say it's worth to, say, the Ontario economy or the US economy, or... what was it? Is it 10%? No. I can't remember. There's a statistic for how much. It's quite alarming, like the number of advisories that they do have on beaches. Yeah. No one likes to, drive all the way out to the beach and there's an advisory. But they do have good apps now as well, where you can work out. You can look to see whether your beach is closed.
Really? I didn't know about that.
But then the big thing with E. coli is you take the sample. It takes 24 hours till you get the results, and everything's changed within 24 hours.
Right.
So when you have a beach advisory, that's because the day before the E. coli levels are high. It doesn't mean the day before that the current day the E. coli levels are high.
Yeah, so you could maybe have the wave action come in and
changes everything. Yeah. So a lot of health units will, on maybe less popular beaches, they'll sample once a week. Okay. Whereas the concentrations are very variable over the week, so that's not, Okay. So kind of the new thing, say the Chicago beaches, they do forecast modeling. Okay. So they have statistical models where they measure a whole lot of different environmental parameters, such as the turbidity, what the waves are, what the rainfall is, and they turn that into, we think there's a advisory, like they'll issue advisories based on running those environmental data through a model.
So you're basically correlating those different metrics to what should be a high E. coli count for that day, and thus being able to get that real time. Let's just put that probe in the water. Yeah. All right, we've got these numbers. Yes, there's probably E. coli here. Yeah. So you don't actually have to then go measure for E. coli itself and have to wait that 24 hours. You can right then say, all right, if the beach is safe today, everyone can come out.
Yeah. And they have done a lot of, I don't know what stage it's in, but they've done a lot of testing in terms of, is the model, you can't trust a model, but is the model telling us what it should?
Is at least fairly accurate enough that we can tell the public that this is probably what's happening. Interesting. Yeah. So you also do lead water level counts?
Well, we do. So in London, a lot of municipalities, they have, the issue with high lead levels in the drinking water. Okay. So we do some work with the City of London. I think it was about 8 years ago. It was front page news, the high lead levels in the drinking water, because they had lower pH. So when you have lower pH, the pipes are a little bit more corrosive, so you get high lead levels in the drinking water. So we do work where we've been working with different municipalities in Ontario to look at how we can change the pH or the alkalinity or different additives in the drinking water treatment plant to reduce the lead levels of the in the drinking water.
Yeah, because I know being from Michigan right now, we have that, I don't know if you guys heard about Flint and the whole issue.
In everyone?
Yeah, I was assuming you guys heard too, but sometimes
Yeah.
it's interesting to see what translates across the board
Yeah.
that makes big news over here. I always listen to the EC Radio Canada out of Montreal,
Oh,
just so
okay.
I can have fun trying to like see like what's the big news that's going on over here. Like, is it really important, or is it just the American news stations blowing
Okay.
things up?
No, well, I was in Australia and it was pretty big news there. Yeah.
Okay. But yeah, so I mean that's a big issue out there now. So how did you guys kind of like manage that here in London? Was that like how long did it take you guys to be able to get back and have like the public's trust back from the lead levels and like because what Flint happened within this past year? So like how long are we kind of?
Yeah, well, I mean, Flint was a much bigger thing
Right.
than London, Ontario. It was before my time, but I mean, they
Okay.
definitely, as where I was from, paid news, but it probably took them a couple of years to really recover the trust. But I mean, they've changed the pH levels at the treatment plant. Like it's very, and they have a lot more like routine household testing now.
And do you guys get to be part of that, or is that all in-house with the city, doing that kind of testing, or do they like ask the university to help them out or so?
We help them, myself and another professor that's at Western. They run pipe loops. So in their pump station, they had pipe loops where they run. So they pull out lead pipe out of the ground. You have to be really careful with how you pull it out. And then they set it up and they run experiments looking at if we run at this pH, what will that do to the lead level? If we run it, and you see seasonal effects where you get high lead levels in summer compared to winter. So we help them. Analyze that data. And we ran some kind of just simple water quality models showing how, changing the pH of the alkalinity would do this.
Okay.
Yeah.
All right. So you also do green work too.
Yeah.
So talk about that, because I really like the idea of anything that helps the urban setting become a little bit more green and also sustainability too.
Yeah.
So tell us how green roofs work. Why are they good, and then what actual research you guys are doing with them.
Sure. I mean, so green roofs are. I mean, green roofs they're very well, like somewhere like Germany, it's been, they look at us now studying green roofs and they were all over 50 years ago. But I mean, green roofs are, I guess, an increasingly popular kind of low impact development tool for probably the big driver in Ontario anyway is for stormwater management. So somewhere like the city of Toronto has mandated that buildings, commercial and industrial buildings, over a certain size, they should have a green roof. If they don't have a green roof, they have to have other ways to manage their stormwater. So essentially green roofs, how they work is, in terms of the benefits they provide, is that they provide a storage within the roof. So when you have green roofs, obviously a lot of people, when they think of green roofs, they think of, maybe large vegetation and gardens on roofs. Green roofs are often just a very low-lying canopy of a vegetation. Sedum's probably the most commonly used green roof.
Okay.
And what green roofs do is that you've got available water storage within the soil. So in your garden, when it rains, the water will infiltrate into the soil and it will be stored within there and not directly released.
Okay, so you're
into
not
the
having like that
stormwater.
hardcore runoff that could cause like storm events.
Yes,
where you have the flooding in the city streets and stuff.
Yeah. So if it rains and it hits the car park, it just runs straight off. Okay. Whereas when green roofs are trying to restore an urban environment back to its previous, rural conditions.
Okay.
So when it rains, the water's stored within the soil.
Okay.
So I mean, and that reduces the peak runoffs that you see after a storm event. It delays the runoff. Okay. So rather than everything hitting the drain, the network straight away, it will delay that runoff process. So that's one of the benefits of green roof. The other benefit of green roofs is reducing the heat island effect. So the thermal benefits in terms of green roofs, because they evapotranspire the water, you get a heat that's lost. So basically they have a cooling effect on cities as well. So that's the other main benefit of green roofs.
Like, how much of an increase will you see in those heat islands, say being here in London versus if you're 10 miles out of town? Like, what kind of differences are you looking at roughly? I mean,
I don't
I'm not
know
looking
what the
for
numbers
exact
are.
numbers.
Yeah, I don't. We work with an excellent kind of urban microclimate guy, and he would answer your question directly. But I mean, I don't know in London, but somewhere like City of Toronto, it's, they look at how, the microclimate around the city can change, the weather patterns around the city. Yeah. And the work that we do is, we had a large green roof grant. We have a few green roofs around Western.
Also across the country in different climates as well.
Yeah, but as I say, we have green roofs here. We initially kind of started off as student projects. We got a larger grant and we set up 3 identical green roofs in different Canadian cities. So to look at, so we had a green roof in London, we had a green roof in Halifax, and we had a green roof in Calgary. So very distinct climates within Canada. So Calgary, super dry.
Or prairies close to the mountains there.
Yeah, but it's very dry. They get large precipitation events earlier in the summer. Halifax is more your maritime climate, a bit drizzly and cooler temperatures.
A nice little middle temperature.
And so we set up the identical green roofs in all these 3 cities, and looking at how the stormwater benefits of green roofs compare in these different climates, how the thermal benefit, the kind of the cooling benefits. And then we have, there's a lot of different design parameters when you're looking at green roofs, like how deep the soil media is, what type of plant you use. A lot of green roofs, some green roofs will be flat, other people will install green roofs on sloping roofs. So we were looking at all these design parameters in the different cities to see how, how these, the stormwater benefits of the green roofs.
Yeah, so what combination works best to help control that runoff? Okay.
And a lot of it from our work, a lot of it comes down to how much evapotranspiration you have.
Okay.
Because if you don't have evapotranspiration will, remove the water, so you then have water available in the soil for the next storm event.
Okay.
So if you don't have evapotranspiration, you don't have the cooling effect, you don't have as much water storage that's available in the system.
All right. So talk to us a little bit about the modeling you do. Like, how do you go about that? Like, I don't really do a lot of modeling. I'm just out in the field and crunching numbers and just kind of throw it all out there. So explain exactly what it is you're modeling, how you do that.
So we use commercial groundwater modeling packages.
Okay.
But essentially it's trying to tie in the physical groundwater flow and recirculation patterns that you get from the lake water infiltrating.
Is there an importance here, modeling or ATM or whatever? I'm searching for an ATM actually.
If you walk down the main road straight, there's an ATM there. And there's a Tim Hortons there.
Okay, thanks.
That's a very Canadian question.
Yeah.
Where's the Tim Hortons?
Yeah, I told my mom's traveling with me as we're heading to a wedding in Maine. And I told her, we can't go through Canada without going to Tim Hortons. We have Tim Hortons in Michigan, but there's something about going to Tim Hortons actually in Canada that you just have to do there. It just tastes that little bit better for some reason.
Oh, yeah?
So, yeah. I know it's all mental, but it's just, it just, for some reason, just has that extra special. I think it's just because you feel good because you're actually going to a Canadian Tim Hortons rather than going to the Michigan Tim Hortons.
That was just funny because that's such a Canadian.
It is.
Tim Hortons is. In every building, maybe every third building on campus, they have a Tim Hortons. Like long lines every day.
Yeah. Well, in Massachusetts, you go there and you have a Dunkin' Donuts on every corner there. So yeah, you will not miss it for sure.
Yeah.
But no, sorry, go ahead with the
No, that's good. It's really trying to tie in and understand how the physical groundwater processes and also that infiltration of lake water onto the beach and recirculation patterns within the beach affects the bacterial transport. So we use standard groundwater flow and transport equations, but we also tie that in with colloid filtration theory equations, which have been used quite widely to describe bacteria transport. but also other colloids like nanoparticles that are used for remediation. Potentially you could use it for microplastic work as well. But yeah, those have been, we've managed to use that quite successfully in matching what we mesh out in the field as well. So it's been quite successful so far. So for the work, and then we can use that model then to try and modify simple physical parameters like beach slope or the groundwater gradient on land, and see how that affects the flow and transport processes within the beach and the bacteria build up over time as well. So yeah, so it's really just trying to understand the underlying processes that affect it.
So where do you guys go for conferences? Like, where can people, actually hear you guys talk about your research? What conferences do you normally go to?
You have your favourites.
We do normally. We often will go to the Great Lakes Beach Association conference.
Right.
This year it's been held up on Lake Superior. It's up in Michigan, North Michigan. So we will every year. We generally will go there. It's a really good conference in terms of beach managers, health units, different government organisations. It's a bit more of I would say, a practical conference. People are there, they've got problems on their beaches, they're trying to look for solutions. So every year we'll go to that conference. We try to go to IAGLA as well.
I'm a big fan of IAGLA. In fact,
I'm
even sporting their water bottle right now.
And then we, we'll internationally, if there's national conferences that are close, we'll always try and attend them, like the IAH, the Hydrogeologists, International Association of Hydrogeologists will attend, because we kind of work at that interface between the Great Lakes, but we're also working with the groundwater and the hydrogeology community. And then internationally, we'll generally go to the AGU, which is the American Geophysical Union conference meeting in San Francisco every year. It just depends what comes up. Like I was recently in Australia at a conference, which is a kind of coastal aquifer management swim conference.
All right.
Yeah.
I would say that's the typical conferences.
Not bad. So, in your field, I noticed that you guys both have engineering backgrounds. Is that the usual standard for getting into doing water quality? How did that background help you guys with jumping into water? Is it more no. I'm coming from the wildlife biology side and stuff, so it's some of these questions, I don't know, because I don't really do a lot of water quality. The only thing I've done is stuck a Y-side probe into my water, and it gave me some readings, and I'm trying to understand that, but that's definitely not my strength of anything at all.
No, it's a good question. So I would say our research really sits in between engineering and science.
Okay.
So you would have researchers that do similar to what we do, but they might be in, earth science. Or, you can have hydrologists that look at how water flows, but they might be in geography.
Okay.
Right? So I wouldn't say we're not traditional engineers in terms of we build things and we're trying to develop this particular process that's, Green Roads is different, because then we are looking at, engineering design parameters. But I think we really, in terms of environmental engineering, where we come into it is that we're using a lot of applied math, particularly when it comes to modelling. So developing these computational and numerical models these are skills that we learn, within engineering. So, say at an undergraduate level, I teach numerical modelling for environmental engineers, so groundwater, surface water modelling. So it's really, perhaps the field work we do could be engineering, it could be science. Once you get to a research level,
it kind of all blends together.
But I think, in terms of the engineering, it's really once we're developing these computational models, and then a lot of quantitative analysis of the data rather than, and trying to really understand, say when we're looking at bacteria transport in beaches, really trying to understand what are the fundamental, how is the flows interacting with the bacteria and the bacteria transport to, understand through the model development.
But in terms of students, I think we've had both environmental science and environmental engineering students backgrounds as well.
Yeah.
Well, I think you need that. Like, I mean, no matter what you're in, it's nice to have those like outside thought processes coming into something. Because my advisor, he's more of a traditionally an upland wildlife guy. Like, he studied wolves, he did weasels, and that was his background before coming in. And then within the last 5 to 6 years, he's gotten into coastal wetlands work because we got a big, huge grant that came to CMU, and there was some bird and amphibian work with that, and so they're like, hey, come hang out with us and do that. And so now he's jumping into all this coastal wetland work where for him, like at first it was, what can I bring to that? But he's got these different thought processes that maybe coastal wetland scientists don't necessarily have, so he gets to bring in that unique thought process, and so now you get to expand that science in coastal wetlands because you have that different thought experience. And so I always like that when you can blend things because you can think so much more outside the box than this stuff and hope to find solutions. So.
Well, it really is when you're talking to people, often when you're talking to people, in another discipline or they might, I'm traditionally, I say a groundwater person, but when I'm talking to people that do surface water, and they might take time series of, let's say, water levels, and the way they analyze it is different to what we might do in groundwater, but that's when you can actually get, let's see how they do it, and I'm sure that we can apply it to what,
So talk to me a little about what Restore is, so the work group that you guys have here. So there's a couple other professors that are in that?
Yeah, so there's 2 other professors, Jason Gerhardt and Dennis O'Carroll. So Restore is our research group within civil and environmental engineering at Western. Really we looking at anything related to groundwater, contaminant transport, remediation of contaminants. And we try to create, a cohesive research group environment for our grad students to, because Jason Gerhardt and Dennis O'Carroll, traditionally they're probably more, not now, but, they do groundwater remediation, contaminant, like how groundwater contaminants move in aquifers. I mean, now they do what, Dennis works in green roots or in other areas, but it really, we find it really beneficial. We work together, we share our labs, and our graduate students share ideas. So even though more of my students might be working on groundwater, coastal water interactions and things related to the Great Lakes, other students who might be doing a groundwater remediation field trial might be using certain field methods that match together. And then we have weekly research group meetings every week, so the students can take turns presenting ideas and presenting their thesis.
I think it's
social
also,
events.
I think it's also been very beneficial for the students to be within that environment with different projects going on as well. So some students from the beaches group have had experience on the field sites at the remediation sites as well. So that's definitely a plus for their CVs. And experience.
So for the students that might be doing numerical modelling, they have the experience that they can go down to an industrial site to spend time in the field learning, how we do groundwater samples, how they set up a groundwater remediation system in the field, but then they can also go to my field sites and look at, how we do groundwater surface water interactions and really get hands-on experience, because, when we're in the field, often it's like, it's all in, like, everyone has to help out. But it means that then when they're applying for jobs, they have a much wider understanding.
And they're more open to different jobs than that they might be able to apply to.
Or my students that are working on, say one of my students that might be working on fecal contaminants at beaches, so looking at E. coli at beaches, because she's been part of our Restore research group, she understands about groundwater contaminants and different organic contaminants and different remediation technologies, which is much broader than if I just worked in an isolated group.
So it expands it out a little bit more. We have a little bit of that at CMU where we have different labs and we're collaborating. We do the lab meetings with multiple labs together just to help, because some of those labs are smaller, and so it's nice to be able to have that larger community that you're a part of. without it being the whole entire department. Like, there's no way that you would ever get through a meeting if you did something like that. Maybe have those little select groups within the department that are somewhat related. And,
Yeah. And I think, and particularly I think for students, graduate students who are moving in from out of town, it's like a lot of our students, our graduate students, are not from London.
Oh, okay.
So it creates an environment where they can come, and it's almost like they kind of have a family story.
Right.
You know, they have people that they can.
No, I mean, it's very important. We have a number of students from out of state that come to Central Michigan, and so to be able to have that sense of community while you're there is so important to help you get through. If you're happy, you're going to do a better job, and you're going to do better research, and so it benefits everyone. So having that sense of community is so important, because you don't want to just be that lone person in the lab, because you're just never going to get through. You're going to be, why am I here? But if you've got those people around you to support you and help you out, it just, the science and you just blossom. And it's neat to see people grow through their grad student experience because of that.
Because I think that the experience students have through their grad studies is really important. You know, also for training, like whether they like research or whether, you know, and a lot of teamwork is required as well. Like when we're going into the field, we might have, you know, some days only 5 people, some days it's 10 people, and it needs to, you know, you all need to, you've got your own research project, and I think everyone knows that they are working as part of a team. So.
Well, and I think it helps too. You are setting up network connections that you have, because once you leave here, you're going to be at different universities or different agencies, and so you have those people that you can pull on and say, "Hey, I've got this project. I know this is your specialty. You want to come help out with this?" Or they might say that to you, and so it allows you to maybe have those future collaborations with people. So you already have that network help set up. So when you have to go start fresh at a university, you've got those people that you might be able to call on and say, "Hey, you know, I want to be able to start this here. I know your specialty with this. You want to come help out?" And I think that's one of the big reasons I've had people tell me why it's so good to diversify your education at different universities, because that way you can build that network of people and have those different communities that you can pull on when you need to later in life. I guess the last thing I'm going to ask, and then I'll open it up for questions for the viewers that we have, is tell us a little bit about Western here. Like, how is the university? Like, tell us about the program here. That, you know, just like the overall branch. How is Western? You know.
I mean, so Western is. It's one of the, I guess, research-intensive universities in Canada. We have all the different faculties, you know, within law, science, music, the business school, engineering. Engineering program has one of the lowest student-to-faculty ratios, which is really nice. So I think Western always does. It always tops out as, you know, having the best student experience, because you know, it's smaller class sizes. You know, a really nice campus. You know, for students to be actively involved in different activities, and but I mean, you know, it's a smaller university than say U of T, but it's a nice university because it's very compact and close together, and all the students that are in residence in their first year. You know, but I think from a research perspective, there's a lot of you know, excellent researchers, very, you know, good research services to help develop any, you know, ideas that you might have or any proposals that you put in. So in terms of engineering, we have all the main forms of engineering, you know, chemical, mechanical, electrical. How does it compare to, you know, I mean, it's from UQ, which University of Queensland, where I was in Australia, I would say it's a smaller university, but it has everything. It has all the facilities. It has great facilities, great labs. You know, particularly in Canada, I would say we have incredible infrastructure funding. So it's you know, through the CFI grant program, it's quite remarkable how the amazing infrastructure that we have. You know, within you know, civil environmental engineering. So for instance, we have a lot of strength in wind engineering. We have a windy dome where they can basically simulate tornadoes and downbursts. And so, you know, it's really a world-class facility, and it's only possible because we have this incredible infrastructure funding within Canada. I mean, I don't know how it compares to UWA. I mean, it'd be small.
Yeah, it is, but it also has, I mean, for its size, it also, Western has a very good reputation in terms of its engineering research
Yeah.
work.
And there's a lot of people within environmental engineering, within chemical engineering, that look at different water, whether it's water treatment, wastewater treatment, whether it's looking at water quality and the environment, groundwater remediation. There's a lot of strength here within the water area. And then also, you know, in biology or in a lot of, or in geography, people working on, you know, Great Lakes water quality issues as well.
Well, we've got some users there, so if anyone has any questions for Claire and Ming, go ahead and start sending those in, and feel free to ask anything about Great Lakes, groundwater, E. coli, green roofs, anything about the university here, Western Ontario. They're open for pretty much anything. So, give them a few minutes to see what questions they can come up with, or if they're going to be shy. And if there's more intensive questions that you want to ask, that you feel like maybe it's something we won't be able to answer through Periscope, also feel free to either tweet us at our handles, or with Claire, it's better to email her. So our first question is from, let's see, Science of Michigan. Hey guys, really enjoy learning about your work. How do we better predict E. coli advisories?
So I guess there's a lot of work that's been done looking at forecasting modelling tools. So, you know, I think that's probably where either we need faster ways to analyse when you know, people go out and they take the water quality measurements. But I think, you know, building these, or they've had a lot of success, I would say, in terms of these statistical regret, these models that they use, where they can put in a wave buoy, look at what the currents are, look at what the rainfall is. And so I think really the continued development, which getting these models right, you need data. And so part of it is getting data for a particular beach, and then training these models for your particular beach. You'll get the best results.
So you just need those long-term data sets to really be able to fine-tune that model.
Yeah.
So.
And that's probably, I think, at the way that's currently the state of the state of the art at the moment, in terms of, you know, recognizing that when you take a water quality measurement, it changes the next day. But if we can get these forecasting models working,
that way you can have better predictions.
Yeah.
And then also, like, once you have those predictions, then maybe you could figure out ways to help combat it at those times if you know those are going to be really bad times for E. coli. Okay, what are the instances they're calling that, and how do we stop that from happening? So, question from Science of Michigan: how do you think deploying these models to the public might work?
Well, I think I mean, they do. It's about something like apps. Like, I think that I'm not. It's not really my area, but I mean, they do have. So you might have the models, they get run automatically, but then they can send the results out through apps to say, this is, you know, we think that at the moment there should be a beach water quality advisory, the E. coli levels are high in the surface water. So I think, you know, there's so much technology now to get the information out to the public, and they are using that, definitely. I think the beach water quality community has been quite successful, particularly in the States. Less so, I would say, in Canada.
Okay.
Like, it's saying that in the States they have much better dissemination tools in terms of the apps that have been developed. I think it's taking time within Canada to develop that.
All right. So definitely might be. Another question from Science of Michigan: will your work be able to decrease that 24-hour turnaround on alerts?
Well, I think the predictive models will. Our work will. The work that we do is perhaps trying to understand E. coli buildup in the sand is a little bit more fundamental, because we're trying to understand why is it that waves are increasing these E. coli concentrations, which can be then used to improve these predictive modelling tools. But it's these predictive modelling tools that will improve the 24-hour turnaround, because you're measuring what the current environmental parameters are, or, you know, what they were the last 24 hours or 48 hours, and you use that current data to say, this is what we think is happening now.
Okay.
But then there's a whole nother suite where people are trying to get rapid detection tools, and that's a really important area as well.
Yeah, it seems like those apps are becoming the wave of their future. There's a lot of invasive species reporting apps that are going out now, and that seems to be doing really well. Like, every state seems to be developing their own reporting app. And so what's nice is that is like you can have people take a picture of the animal, send it in. It also has a GPS point, so you know exactly where to go out if it's an animal that you need to like go address it right at that immediate moment. And so, and it helps them verify rather than like say like, you know, I study mute swans. Most people can't quite tell the difference between a mute swan and a trumpeter swan, even though it's got that bright orange beak. But once you know, you know. So the mute swan's got the bright orange beak. The native trumpeter swan has the all black beak. But if you don't know that, you're just saying, I just saw a white bird. I think it's, you know, an invasive bird, and you go out there and like, no, it's not. Why do we just waste that time going out there to do it? But by having that app and being able to see it, then you'll know for sure. So.
But it's also a lot about, I think these apps are slowly being developed, but people have to, it's about disseminating that these apps exist. Like there was some recent app for Ontario that I did an app or a website, and I didn't know about it, even though I've been working in this area. So it's about, people have to know, and then you've got to have the avenues to disseminate it to the public. And that's where grassroots or NGOs that are working on the front line with the beach communities are so important, because they're the ones who, on the ground level, are the ones saying, hey, you should be using these apps to work out.
Yeah, I mean, like something that really simple that I was exposed to yesterday when I was at Wayne State University talking to them. Like they handed me these invasive species playing cards, and here I'll ask the question real quick. I'll get back to that. Does Western University have researchers working on predictive models alongside your work with accumulation? So we'll answer that in just a second. But anyways, it was invasive species playing cards, and so they hand these out to the public, so it teaches people about these invasive species to be on the lookout, because it's the watch list of what could be coming into the area. It's such a simple way, and I think you could do things like, you know, it's such simple ways that you interact with the public to help teach them about stuff, so there's got to be simple ways to be able to let them know about these apps, you know, where not it's, you know, maybe just putting the ad out on Facebook or something like that, so people see that, you know, as they're scrolling and things like that, so. But
so are we using, at the moment we're not, we don't use predictive models per se, we're more looking at more the fundamental processes and trying to understand, well, is this beach more likely to accumulate E. coli within the sand, is it more likely to be a problem here? But in the future there are certain findings from our work that we would like to, I think, work with other researchers who are doing predictive modelling in terms of saying, okay, we now understand that, for instance, if you have had very calm conditions for 5 days and you have a wave event, that's going to lead to high water quality in the surface or high E. coli levels in the surface water, compared to if you have regular waves occurring at that site. So that kind of information can feed into predictive models. We don't do it per se ourselves at this stage, but I think in the future we'd like to work with people that do, to try and help them put the work that they're doing into those models.
Okay. Any other questions out there? We've got Claire here for a couple more minutes before we have to let her go, because she's very busy today. She's got other researchers visiting, so I could only score her for about an hour here. So if you've got any last questions you want to ask, now's the time. Otherwise, you can get a hold of us after the Periscope.
I mean, you can always email me at any time. Happy to answer questions.
And definitely check out their the Restore website online. It's a good place to get information about the work that you both do. Seemed to be a pretty robust site when I was stalking you guys online before I showed up.
Yeah, so it encompasses everything our research group does, in terms of the groundwater remediation work, the different remediation technologies that Jason Gerhard and Dennis O'Carroll are working on. Because I mean, our work is really quite broad across the groundwater
spectrum.
Yeah, spectrum.
Okay. Well, with that, if there's no more questions, I'll wrap things up. So I'll just put up the Twitter handles for everyone again, if you guys want to grab the screen grab of that. If you didn't catch the whole broadcast, or you want to be able to listen to it again, you can go on to my website at wildlifebiogal.com. There's the links to Periscope, YouTube, and podcast. This is from Science in Michigan, not a question, but thank you for your time sitting down to talk and share your work. So yes, thank you both very much. But yeah, so go check those out. I will have the podcast up within the next day, and YouTube probably also within about the next day too, so you guys can get those links. And then of course, now that Periscope lets you actually have the videos up for more than 24 hours, you can always go see the video on Periscope there too. So with that, I'll thank you guys both, and we'll be signing off, and see you guys all later.
Yeah.
So why don't you just tell us a little bit about your background?
Sure. So I started out in my first thing I ever did in academia or in wildlife research was looking at hoary bat guano. So I was digging through stomachs and intestines of dead hoary bats and making little slides out of what I found in there, so to look at their diet. And I was hooked ever since. So then I went and did some interning for the DNR in Minnesota, working on white-tailed deer, and then that kind of propelled me into doing research on mountain lions, which is where I went to grad school at Southern Illinois University, working with Dr. Clay Nielsen on habitat modeling and dispersal corridor modeling for mountain lions in the Midwest. And then after that, I had enough GIS experience and some other experiences, remote sensing experience, and then I got a job at the University of Minnesota where I basically was hired to be a GIS person, even though my background was in wildlife and things, but I knew enough GIS to be dangerous, so I made a lot of maps for the United States Antarctic Program, and it was through that experience that I became inspired to do my PhD, and so I did my PhD at the University of Minnesota starting in 2011, and I got done in 2014.
Great. So I just have to ask, because I've got a niece and nephew who are 9 and 6. Do you have any good bat poop stories that you can tell?
Bat poop stories?
Yeah.
That is the first time I've been asked about bat poop. I get asked about penguin poop all the time.
Well, I'll ask you about penguin poop. You've got some good stories for that.
Well, see, and this is the moral of my story so far in life, is everything comes back to guano, to poo. Everything comes back to poo. I started out doing hoary bat guano. A good bat. So actually, one of my favorite parts of doing this job, so I would work in the dark because you'd have to look into a microscope and look and sort through the bat guano and find all of the things that were identifiable of the parts of the insects that they had eaten.
Okay.
And so it was really nice and dark in there, and it was, and the light of the microscope was really bright, and so every once in a while you'd be like scanning through and looking, and you'd end up with this like crazy like water beetle claw or something that was like really, really hairy, and those were always really fun. So that's really the only like fun thing that I would say was fun. It's like finding something that was
just
like big and hairy and like a claw.
Like it was something
it
there.
was great. Yeah. Otherwise, a lot of it was just a lot of like wings and things that were boring.
Okay.
So like chelicera and feet and things were always really fun.
Right, like any of that like big name stuff was always like, oh, there's something cool.
Exactly.
I can see the structure to it. And
Jackpot.
Yeah. The excitement of it.
Yep.
So penguin poo. We'll just get those
Move
all
on.
shots off the list right there. Yeah.
Poop, people.
Yeah.
Want to learn about poop? Here you go. So in Antarctica, penguin guano is incredibly important for me as a person who's looking at their populations from a very large scale, continent-wide populations. Their guano is what tells us that they are in a particular location, which is fantastic. So in the case of emperor penguins, they live only on the sea ice, and they leave a really nice guano stain that is brown when you're looking at it from the high resolution imagery.
Okay.
So that tells us that they're there, which is the first indication. And then we use some remote sensing techniques to kind of tease apart the pixels that are guano, snow, and then be able to tease apart the ones that are actually penguins. So that's how we come up with their population estimates. And then in the case of Adelie penguins, the other true Antarctic penguin species, they also live within their guano. They leave a really big, nice guano stain. And the size of the guano stain is correlated to the number of animals that is actually there at the same time. So in other words, the more guano, the bigger the population is. And so that gives us the ability to watch their populations through time and be able to see what causes their populations to go up and down at a very broad scale, rather than just looking at very population-wide or even just regional-wide trends.
Is that something very common with birds, where they'll just stay right there? They don't walk off a little ways and come back. Like some, mammal species like raccoons, they'll always have that select little spot that they go to, not necessarily where they're living. Is that something that's very common with birds?
So, well, that's a good question. So, at least in penguins, at least with Adelie penguins, they will come back to the same nest sometimes. A lot of times they'll come back to the same exact nest every year. And we think with emperor penguins, a lot of times they'll do that too. They'll come back to the same spots, but not necessarily. When times get tough, what we're finding now is that they'll actually move around a little bit. So if the environment gets to be in a situation that's not very favorable, they can be a little bit more plastic in their behavior and move around. And we know that because we're able to watch the populations through time.
So, like, can you tell, like, I mean, just by, you know, the marks in the snow there, that's how long that they've been there? Like, does it build up, like, you know, is like the coloration different so you can tell like how long that particular colony has been there?
That's a great question. So there's two different types of guano that we look at. So you're right. So the guano for Adelie penguins will build up in there, and that's one of the things that's really important to pay attention to, is because if a population was really big and then shrinks, you need to be able to make sure that you can figure that out right. So the new guano is pinker. It's pinker than the older guano.
I never would have imagined it being pink.
Yeah, so it's pinker. So the older guano is this kind of light brownish beige color, and then the newly deposited stuff from this current season is really, really pink, and it's the really pink stuff that we are interested in being able to track their populations through time.
So with the satellite imagery that you're using, how does that work? Like, explain to folks out there who might not necessarily know how you use satellite imagery. Like, how good a resolution do you get? You know, just kind of maybe walk us through the process.
Yeah, so the satellite imagery we use is what's called very high resolution. So that means it's spatial resolution, so the size of a pixel is like this style. Okay. In contrast, so that's like about 30 centimeters. Some of the high resolution images are like 60 centimeter resolution. In contrast, like Landsat is 15 to 30 meter resolution. So this is like hundreds of times finer detail. And so what that means is an animal like an emperor penguin will take up several pixels rather than being all within a single pixel. So that's how we can tell what we're looking at.
Nice. So do you use anything else besides satellite? Have you thought about like doing something like a UAV or a drone? Was it working? I mean, is it possible where you're at? Like, I'm thinking, you know, you're down in these Arctic regions. How well do you think like a drone will work down there?
So I've never used a drone myself. I think there's a lot of potential, I think, for drones to be used in the Antarctic. The one thing that I'm, I guess not skeptical necessarily, but I'm concerned about is the fact that it's really windy. And so wind can definitely, like if you wanted to even plan out a course and fly a drone, I feel like it would be very easily, you know, swept off course pretty easily, and I think the wind is just a huge, it's potentially a huge problem. So I know some people have used like little quadricopters and things from ships and gone over. So I think it's a matter of just working on the technology to have yet another layer of kind of ground validation and looking at what we're seeing on the ground. Because a lot of these colonies, even if you wanted to get into them and count all the birds, you just couldn't. So you have to have some sort of aerial survey.
So do the aerial surveys, you find that helps you quantify those populations a little bit better versus visual sight? You know, I know when I've gone out and done my mute swan surveys, if I have a large flock of 200 swans out there, it's hard. Even when you have 3 people on that boat counting, you're going to always come up with a different number. But do you find that with having that imagery, does it make it easier to like be a little bit more precise? Personally, the more counts you can have from different sources, I think it is better just to have a different, several different ways of validating. Just because, like you said, if you're counting from the ground, your perspective is very different than it is in the air, which is also very different from the satellite imagery. So I feel like, for my purposes, I'm always interested in making sure that the satellite images are validated with whatever we can get from the ground. Just try to kind of make that the gold standard of being able to monitor populations through time. Do you think it's still maybe like at the point where like human, with the binoculars might still be better, like because the resolution isn't quite there where you can pick out stuff? Oh yeah. Okay. We're always we'll always need some sort of ground validation, just because they're starting to do things now, or at least we're starting to learn about some of the behaviors that they have that we didn't know before. So it's going to be critical to continually validate what we think we're seeing on the imagery, because if I think I'm counting or coming up with an estimate of, say 1,000 birds at Cape Crozier of emperor penguins, I need to make sure that that's actually real, and so we just continually, I think, should have that ground validation. So since you do a lot of work in the Antarctica and Arctic, what inspired you to do that? Some researchers like to stay around areas they know. What drove you to want to go work in the polar regions? It was kind of just sheer luck that I got the job in Antarctica in the first place, making maps for the United States Antarctic Program, just because I had GIS experience. So that was kind of luck. And then as I was doing some of this map making a few years into it,
we got access to this high-resolution imagery, and it was just kind of messing around with the imagery and exploring. I found that you can see seals and emperor penguins, and did a little bit of research and found that somebody else had done kind of a pilot study on emperor penguins, and that was when I realized that I wanted to do a PhD. And then after I did my emperor penguin work, I was approached by a colleague of mine at the University of Minnesota, Seth Stapleton, who does research on polar bears, and he asked me if I wanted to work with him on a polar bear project. So that's how I got to go to the other pole. I haven't been there yet, but that's how I have done work there.
Oh, okay, got you. Oh, so you've done some cougar work, and I know in Michigan it was kind of controversial for a while if there were cougars or not. It finally was, we were able to establish that they were there, but it's thought that a lot of the cougars are dispersing from those western populations. So what can you tell us a little bit of how cougars disperse across the U.S.?
Yeah, so my other work I do is on mountain lions, and what we're finding is, so when I did mountain lion work for my master's degree, and so that started in 2005, and as of 2005 there were like handfuls of confirmations each year. And so when I say a confirmation, that's really important because this is not a sighting. These are like verified pieces of physical evidence of an animal in a state that's not like in the West.
It's not someone just on Facebook saying, hey, I think I saw something out there.
Yes, because otherwise,
actual,
they would be all over the place if that were the case. So what we think is happening is that the West has basically become full, and there's effectively no more room at the inn. So these subadult males are effectively being kicked out of the West, and they have to go somewhere. And the Midwest is this place where there aren't any mountain lions, and they're not going to get beat up because there aren't any mountain lions. And so they're moving east. And so that's what we're finding, is that a lot of these animals that end up as carcasses, unfortunately, are subadult males for the most part, and their genetic structure is very well related to a lot of the populations out west.
So mountain lions used to be in the eastern U.S.,
They did,
correct?
yes.
Okay.
Yes.
So
they were extirpated.
All right.
Yes.
So they're just. So do you think any of these coming back, or do you think they're going to be successful when they come back? With like the public perceptions of it, also maybe the genetics are slightly different from what the species, that was originally, well, it was all one species, but the original populations that were over here, do you think there might be some differences in behaviors that might not make them as successful?
So I think there's two questions. The first question is whether or not they'll make it, and the second one is whether or not people will allow it. Those are two different things. So I think we've done some modeling work, and that suggests that mountain lions are likely to reestablish populations in the Midwest within the next 25 years. And this is female mountain lions, and the reason that's critical to mention is because female mountain lions don't move nearly as far or as often when they disperse as males do. So that's the reason we're seeing so many males in the Midwest, because they're the ones who tend to move. So females don't move as far or as often. And so despite that, we still think that they're likely to make it to places like Arkansas, Missouri. We're already seeing them reestablish in Nebraska. So I think that they can make it to these locations to start breeding populations, providing males also make it. Whether or not people will allow be receptive to these populations actually becoming reestablished is another question. It's worked so far in North Dakota and in Nebraska, but farther east I think is a really big unknown.
Do you think it's just their fear of having that large predator out there? Okay.
Yes, absolutely. And that's part of what we try to do at the Cougar Network. We don't do advocacy, but we do science communication and outreach and research. And that's one of the things that I feel very strongly about, is to provide accurate scientific information for people to make decisions. And the fact of the matter is, you're very unlikely to ever see one. Even if you had one in Missouri, I'm sure there are several in Missouri right now, actually, probably wandering around, and you probably will never see them or know that they're ever there.
Because they're a pretty cryptic species, correct?
Yeah, they're very elusive. They don't like people. They like to kind of hang out in the woods in rugged terrain. So
most places where people aren't going to be necessarily just going for their Sunday afternoon stroll.
Exactly. And they like deer, so they're not going to attack people for any good reason. Yeah.
Well, speaking of science communication, you do an awesome Friday thing called Cougar or Not.
Thank you.
What inspired that? And because I know I'm thoroughly entertained. One of the coolest things with science communication that I had was actually guessing one of your Cougar or Nots.
It's fun, right?
Yeah. I was like, yes. Yeah. It's like, I guess Minnesota. Thank you very much, everybody.
Yeah, exactly.
Yes.
I win. That's right. I know. I felt
Yeah.
bad I didn't have enough to give away to everybody who got it right.
It was just the pride in actually guessing
Yeah.
that it was Minnesota. Like, I had to be like, yes, I guess Minnesota. I was telling everyone.
It was me.
So I think it's a really awesome concept. So please tell us, like, how you came up with that, how you feel that it's worked. Do you think it's, like, been something that the public's been really receptive to, that it's, like, getting your goals across with, you know, with the concepts?
Yeah, so so the first question about how I was inspired, I was actually inspired by Dr. David Steen, and who does Not a Copperhead, and I love that, and I'm like, this is fantastic. So I had seen him doing that for a little while, and then literally just one day I was sitting at my desk on a Friday afternoon in October, and I was realizing how many images, how many photos we get sent of mountain lions that are not actually mountain lions. And I thought that that would be a really good opportunity to talk about the fact that most of the, you know, photos we get are not mountain lions.
Right.
And so I just really, like, randomly just posted a picture on a Friday and asked people to identify it. And then I just decided to continue doing it because I like it. I think it's a lot of fun for me, and people seem to like it, and that's kind of fun. So whether or not it's making a difference, I'd like to hope so. I think that at least my Twitter followers, which is not a ton of people, you know, with respect to the rest of the Midwest, now understand that if you see something that is a mountain lion, it's very, very unlikely to be a mountain lion. So I feel like I've made a difference in that respect. But whether or not it's actually making a difference across the rest of the Midwest, I have no idea. I'd like to think so, that maybe at some point it would, but...
What do people most misidentify as a mountain lion? A house cat, a bobcat?
Both of those things.
Okay.
Yep.
All right.
House cats and bobcats are surprisingly large, according to a lot of people. But
Well,
it's,
my sister's cat back when we were kids, it did get up to about 20 pounds, and it, I swear when it was laying on my chest, I couldn't quite breathe right, but it's still not quite the same
I know,
as a mountain lion.
and that's not to, yeah, and that's exactly right. Like I feel like a lot of people just don't understand how big they really are. Like they're huge animals, and so
like
when
you're
see
saying huge, like what weight class, like for people to like, you know, like what's like average?
100-pound animal would be like the size of a dispersing animal. They can get up to like 150 pounds. They're huge. They're huge.
Yeah. So has there ever been a 100-pound house cat out there?
And we're really not very good. Humanity is just really bad at guessing size. Just generally, like, so if I say a 100-pound animal, I feel like that's a really difficult thing, just generally speaking, to understand what a 100-pound animal actually looks like. And so I think that has a lot to do with the misperceptions. And sometimes when there are images that, when you don't have depth perception, or if you don't have a tree in the way to help you guess how big that animal is, it gets to be really hard. So I can understand where they can be pretty tough. And I get stumped every once in a while too. So there was one, actually, the one that my favorite was a bobcat that was sent to us in Louisiana, and it was coming through the woods, and it was kind of in the shadows, and it was huge. It was huge. So I couldn't really tell if there were spots or if it was because of the shadows that was on it, and it was this really big animal, and its face was kind of in the shadows. So I couldn't exactly tell, and the first time I looked at it, I was like, oh, that is I think it's a bobcat, but I think it's a really big bobcat. So it's hard to do, is the point, to definitively say.
So how do you feel like science communication has benefited your career? Because one of the things, like, I love science communication, and I find that, like, the opportunities that I've been afforded just by being part of that science Twitter community have really helped me out. How do you feel like it's helped you out with your career? So I've
been invited to give talks because of my involvement on Twitter.
Same here.
Yeah, it's great. I meet people on Twitter, and there's actually been, I feel like I've been involved in some actual real collaborations because of it, because we're all out there kind of talking about what we do, and not in a boastful way. It's more along the lines of, hey, these are interesting things, and I'm really appreciative of that, because I am also very interested in what other people are doing too. So to have a platform like Science Twitter to do that kind of communication, I think it's been really great for advancing the messages that I would like to advance and I want people to know. And it's also been really great to meet people and start new collaborations and be invited to give talks about things that I'm very passionate about. So I'm very happy for that opportunity.
All right. Yeah, like I noticed at the end of your talk, you had your Twitter handle up there. Do you find that people actually contact you via Twitter, like after seeing a talk like that? Do you find that that's been helpful?
Yeah, you know, I think I do. I think people start following me, at least. A few people will start following me afterwards. And usually people will come up to me in person after the talk, but if they don't, then they'll be able to contact me afterwards. And I think that's happened probably a couple times. Yeah.
All right. Yeah, I noticed earlier today when you were talking to another researcher here that you guys exchanged Twitter handles.
I know.
And it almost kind of felt like a new way of, we always used to have our business cards, but now I feel like Twitter is kind of becoming that new business card. Do you feel the same?
Oh,
or,
absolutely.
okay.
Absolutely. I love Twitter for that reason. Seriously, because I'm on it every day, and if I want to see what somebody's been up to, having a business card doesn't help me, right? If I want to see what somebody's been doing in the last week, I can just go to and follow them on Twitter, which is really great. And because I think we're a society that's really connected now, it makes a lot more sense to have that ability to have constant connections, and Twitter allows for that.
Yeah, I kind of like to think of it as online CV that you're generating. You send a paper CV to someone, and they see what it is that you've done, but with like that science communication through Twitter, maybe Facebook, other things like Instagram and stuff, you kind of get to see who that person is.
Right. Personality.
And do you like it for that, or are there other reasons that that you like to use it? Maybe things that I haven't even thought of.
Yeah. So I think. As far as the thing that I think Twitter allows us to do is not only be researchers, but it also allows our personalities to come through. And one of the things that I feel very strongly about, actually, as a scientist and also as kind of a de facto science communicator, is the fact that scientists are humans. Like we feel things. Like I care about penguins, actually, and I also think they're cute, and I think it's okay to admit that I think they're cute. And I care about animal welfare. I care about animal rights. Like these are things that we care about, and I think that having the ability to show your personality and the fact that you care about these things beyond just a scientific objective is really critical, because I think there's this perception of scientists that we're just these very like unfeeling robots that generate results all the time, and that's like the furthest thing from the truth. And so being able to do things like this on Periscope and on Twitter really allows me to at least get that out there for anyone who cares to listen.
Yeah, you can say that we're actually fun and engaging people.
Yeah.
We're not just like these data points, with the old thought process of a scientist with their lab coat and just sitting behind, the lab bench.
I haven't worn a lab coat since I did hoary bat crap.
Do you find that being able to network with other scientists on there helps? I mean, not just as far as talk opportunities, but also being able to discuss with other scientists some of the issues that you find, like you have issues with women in STEM, other things of how we deal with that, and being able to bounce those ideas off other scientists. Do you feel that that's helped you at all?
Yeah, so actually, interestingly, the other day I went to Anne Hilborn's talk, the Cheetah Lady, and I didn't understand a couple things about her talk, and it was just not that she did a bad job, she did a fantastic job, and I was like, I need you to explain something to me, and I had a bunch of questions, and I asked them to her on Twitter, and she's like, hey, let's just meet, and we talked for like 2 hours, not solely about that, obviously, but it was great. It was like, I finally get to meet the famous cheetah woman, and it was wonderful, and she's obviously much more than just the famous cheetah woman. She's a brilliant scientist and a great communicator and just a wonderful person, but Twitter allowed us to do that, and I do think it's also really critical, because we did talk about being a woman in STEM, in STEM just in general and in science, and so I think there's kind of this community of like you feel like you belong, kind of, which is kind of weird, because I grew up in in the 90s when there were like chat rooms and stuff, and it was like kind of a weird thing to like meet somebody from a chat room. So I feel like this is kind of like that in a nerdy way, but in a good way, like in a good way.
But I feel like you can trust like people because they know other scientists, so it's not like you're just meeting some random stranger. They know someone that you know, so you feel like there's already that ease when you're talking to someone. You can trust that's who it is you're talking to.
And you're like at a conference, so you're in a safe spot, and you can see, and you have the opportunity to willingly follow these people, and you can see what they're doing and see that your interests and theirs are aligned, or at least similar in some way. So yeah, I think it's really cool. You can kind of know a little bit about this person before So rather than just like cold meeting them, you can
Right,
like kind of
exactly.
see what they're
That's-
doing
yep, exactly.
and have an informed discussion, which is really cool.
Yeah, I think it eases that transition because if you first meet someone at a conference and you've never met them in your life, it's such an awkward, like, hi, how are you?
I know.
Can I talk to you? Kind of have that imposter syndrome possibly going on. And it's just that awkwardness. But I think by talking to someone ahead of time on Twitter, you already have that little comfortableness with them when you actually meet them, and so it's not as completely awkward. And you kind of, some of the people, like I meet them, it's like, I've known you for so long on Twitter, I need a hug right now.
I know,
It's not that like awkward, can I come talk to you? I'm interested in your work. So.
Well, you already have a leg up, right?
Yeah.
So, or you already have like rather than starting out at the ground, you're already up here. Like, okay, and now we have, like I said, it's an informed discussion rather than having all of that back talk of like, okay, where did you go to school and blah blah blah. That crap's already out of the way. I already know what you're studying. I know I want to talk to you. Here's the reasons I want to talk to you, and now we can have a discussion about those things rather than wasting time in the beginning. So I think it's cool. Yeah.
For all the scientists out there, because I've been trying to encourage, everyone from undergrad all the way up to people well into their careers to get onto Twitter and start doing science communication. What advice would you have for people just starting out in science communication?
Follow on Twitter anyway.
Okay,
follow a lot of people. Follow people that you think are really interesting, because that's a really good way to, first of all, watch what they do and do what they do. Follow the people who do things the way that you would want to do them. So, for example, I follow people who are inspiring and kind, and that's something that I feel very strongly about as a scientist. I think it's really good to be trustworthy and kind when you're facing the public, because, like I said, I feel like there's whether it's a realistic perception or not, there's this perception that we're not humans. So I try to find people that are also like that, but also who are doing interesting, groundbreaking work. As far as science communication in general, the one thing that I would really recommend people do is listen.
Okay.
And the reason I say that, again, is it gets back to this notion that I feel like we are sometimes actually perceived quite accurately in some cases. Some people are really not very nice to people who disagree with them or to people who just don't understand. And to somebody who just doesn't understand what you're talking about, to call them stupid, to call them a jerk, or to even be sarcastic in a way that makes them feel uncomfortable, would that make you want to listen to them in the future? Exactly. And so to resist the urge to be like, oh my gosh, you're an idiot, resist that and remind yourself what your actual goal is. And if your actual goal is to educate and to get people being interested in science, making people feel excluded in any way is not the way to do it.
Right. That's really good advice. Because I think sometimes we forget that, we need to just sit there and just listen to what other people are saying, because they come from so many different backgrounds. And, I remember there was a story in West Michigan about these two gals who were out on a tube going down the river, and for some reason they thought that the river would go around in a circle and drop them back off to where they were.
Oh, no.
But a lot of people were making fun of them, but the thing is, I don't think that they had ever been outside the city before. So, like, if you look at it from their perspective, if you've never been on a river before, you might not know that, and to make fun of them, while it might seem like a really simple concept for those of us who go and do outdoor science all the time, to someone else who's never been out there, that's a whole brand new thing, and just to, like, go make fun of them, you just can't do that.
Well, and I just don't understand what making fun of people does anyway. It just makes you feel better, right? Like
Right.
if I am making fun of you because I think you're stupid, that doesn't make anybody but me feel good, right? And so what's the point in that? Why not helpfully, not even necessarily correct, be like, oh, that's a good point, because maybe you've been on a lazy river before, and lazy rivers do go around in circles, but you know what, rivers have to flow into something, and so that's why they don't come back, or whatever. But there's no reason to be rude, and I just feel like I see that too much, and it bothers me.
No, it's a really good point to remember that we're all people and we're all still learning, and
we're all in this together. We're all in this together, and why not be an advocate for, like, hey, guess what? If I want to do some research on something that I think is really interesting, say it's taxpayer funded, you're helping me do that. Why on earth would I disenfranchise you from the work that I'm doing when I think it's really cool? Why not make it really cool to you too? Because you have an investment in it.
Right. So when you're posting on Twitter, what kind of things do you post? So, because for people just starting out, they might not know, like, what should I post out there? I know everyone has their own personal style, but what's kind of your personal style with Twitter and what you post?
So my personal style, I tend to retweet things that I think, I do a lot of retweeting, first of all. I do a lot of retweeting, and I retweet things that I think are important, interesting, fascinating. I tend to retweet things that are educational too. So along those lines, and I tend to also retweet like Antarctic, polar, predator stuff. Every once in a while, I will tweet political things, and I tend not to do that too much, but the reason I do is because I agree with Dr. Katie Mack. We are humans, and we all have a say in this, at least in the United States, we have a say in the political process, and I think it's important to be informed and to have an opinion. So I try to keep that to a minimum, but for a new person starting out, what I would tweet about are things that interest you, because people will become interested in things that you're interested in, and so you have to get that out there. So it's a little bit of allowing yourself to be vulnerable too, because there's always that kind of that question, like maybe people won't like what I have to say, but you have to be okay with that, because not everyone's gonna like what you have to say, and so, but you will find people who do.
Yeah, like when I first started out on Twitter, I was posting just science stuff, thinking, okay, this was going to be my science space, and you know, I've learned over time to kind of let some of my personality shine through, and you know, sometimes I'll just talk about like random, like I post a lot about my niece and nephew up there, because I think that helps humanize me, and also helps inspire people to like help others learn about science, because you see the excitement in their eyes. And then I've even seen, some scientists where they post about what TV show that they like. And it happened that one time a scientist, I kind of knew a little bit on Twitter, but not very well, posted one of my favorite TV shows up there. And so I chatted back with her. Next thing we know, 3 months later, she's one of my best pals out there. All because she posted about some TV show. It had nothing to do with science at all, but it was just, she was just thinking that at the time and put that out. So I think you can let some of your personality go through, and you never know. You might end up with a really good science buddy that, can become a good advocate for you. You can bounce ideas off of. We talk about not only SciComm, but other things like how we're dealing with grad school and stuff like that, all because of just this one random tweet that she put out there.
Right. And knowing that you exist is a good thing. Like, so if you're looking for a job and you're, there's a committee that's looking for people, having like somebody go, oh, I've heard of them, at least on Twitter, that's better than nothing, right? Providing it's a good,
good experience
for good reason, which is why I feel very strongly about being positive in your science communications. It's fine to be opinionated. So I'll let my opinions show through, but I tend to keep like super personal stuff up. So like I try not to mention my partner too much, just because he's not on Twitter and he can't defend himself. I want to tease him or something. So I try to not to do that. But other than that, I love to post things that I think people would be appropriately interested in.
So if you've got any questions for Michelle, go ahead and start sending those in. If not, we're probably going to start wrapping things up, because we've got a final night social that we got to go to. Yeah, and I don't know about you, but I'm kind of starting to get a little hungry.
Yes,
so
slightly.
Yeah, some good food would be good, and getting to go hang out with all of our colleagues here, because it's the last night, so it's the last time we're going to get to see some of them for a good year at least. So. But yeah, since I don't see any questions coming through right now, if you have any other questions, definitely feel free to tweet us. If you missed part of this Periscope, check it out on wildlifebiologal.com. I'll have the links up for Periscope, YouTube, and also the SoundCloud podcast later on. But yeah, for all of you who are interested in science communication, definitely follow Michelle. She's really big with her Cougar or Not and all the science communication. So all of you scientists who have been bugging during TWS to get on Twitter and start doing some SciComm,
Do it.
Yes. So follow us along, and we'll see you guys later, because we're going to go get some food.
We're going to go have barbecue now.
Yep. So see ya. Thanks for joining us.
Bye.